All right, my Math 2 people, here we go. We got lesson 4-5, triangle inequalities. Want to make sure your name and your period is up here. I forgot to put a question at the beginning, so it looks like you got off on this one. You don't have to do a summary on it. So here we go. All right, so there's a relationship between the sides and the angles of a triangle, and here's the relationship. The longest side is always going to be formed by the biggest angle. So what I mean about that is, let's say that these two pens are making an angle. So here's my angle here, and then this over here is my side length. Okay, if I make that angle bigger, that makes this side bigger. If I make this angle smaller, so here's a smaller angle, well, now the side just got smaller. So this just says if I've got a really long side like this from here to here, that means it's a big angle right here that's making it. And then if I've got a really small side, like these two angles here make a small, these two pencils here make a small angle here, that's a small side right there. So the longest side is going to be formed by the biggest angle, and the smallest side is going to be formed by the smallest angle. So here's what we're going to do. On this one, we want to list the angles from largest to smallest. Well, in order to do that, let's list the sides from largest to smallest. So my biggest side, so our largest side, well, I can't spell today. Anyways, my largest, and then smallest will go over here. So my biggest side is BC right there. That's 10, right? So that's the largest side. And then my medium would be right here, AC. And then my smallest side would be over here, AB. Well, this problem doesn't ask me for the sides. It asks me for the angles. So if I look it up here, this says that the longest side is formed by the biggest angle. So we could also go backwards and say the biggest angle is formed by the largest side. So here's the largest side. Which angle is forming that one? Well, if I follow it back, angle A is forming that side right there. So I follow out angle A, and there's the biggest side. So that means angle A is the biggest angle. So angle A is my biggest angle. Which one's my medium size? Well, AC was my medium side. So this is medium. And then if I follow this one back, what angle is making this one? Well, it looks like if I follow this one back, B is making side AC. So B would be my medium angle. And which one is my smallest one? Well, of course, we know it's going to be C, but let's just look at it. C is this angle right here, and this angle has these two sides on it. And those two sides, if you follow them out, they're creating this side over here. So C has to be the smallest side because, or smallest angle, because this is the smallest side. So angle C would be our smallest angle. So big side, big angle. Medium side, medium angle. Smallest side, smallest angle over there. All right, the triangle inequality theorem. The triangle inequality theorem says that two sides of a triangle, if they're added together, then the sum of those two sides is always going to be greater than the third side. What's this saying? It's saying that just having three sides is not enough to make a triangle. Okay, a lot of people say, yeah, three sides can make a triangle. Not all the time. Let's think of it this way. I've got my ruler right here, and let's say that this is going to be 5 inches long. All right, so that's 5 inches long. Let's say, or centimeters, let's say I want to build a triangle, and one of the sides I want to have make 3 centimeters long, and the other side I want to make 1 centimeter long. Well, if I wanted to make a triangle out that, 1 centimeter would only go from here to here. There's 1 centimeter. 3 centimeters, the other side, would only make it from here to here. There's 3 centimeters. Guess I should put the 5 centimeters on top, huh? So what happens? I can't make a triangle out of that because these two smaller sides can't touch each other. And my lights just went off because I haven't been moving enough. So there we go. All right, so the triangle inequality theorem says two sides have to be bigger than the other side. Otherwise, the two sides can't touch to make a triangle. So here my two sides were 1 and 3. 1 plus 3 is 4. 4 is not greater than 5. So that can't make a triangle. So that's our rule. So any two sides, when you add them, have to be bigger than the other side. So that means that this side here, AB, plus this side here, BC, when you add them together, that measurement is going to have to be bigger than the third side. Okay, what if I thought that AB was the biggest side? Well, if I thought this was the biggest side, then BC plus AC has to be bigger than that one put together. So I could say that BC plus AC would have to be bigger than AB, this third side. So any combination of two sides, when you have a triangle, it's going to have to be bigger than the third side. So even if you thought, and you're crazy to think that this one's the biggest side, you would have to prove that AB plus AC was bigger than that one, BC. Let's go back to this triangle from earlier. Okay, so any two sides, 5 plus 10, that's 15. It has to be bigger than this third side, and it is. Let's pick these two, 5 plus 7, 12. It has to be bigger than this third side, 10. Otherwise, it won't form a triangle because they won't be able to touch, like this section right here. They couldn't touch. And then, of course, 10 plus 7 is bigger than 5. So those three can make a triangle because any two of the sides, when you add them together, are bigger than the other side. All right, so this one says, can the sides 11, 12, 24, and 12 make a triangle? The answer is no, they would not form a triangle. Well, you might say, why? Because 11 plus 24 is bigger than 12. That's true. And 24 plus 12 is bigger than 11. That's true. But the two smallest sides, 11 plus 12, they are not bigger than 24. They only add up to 23. And the two smallest sides have to be bigger than the biggest side. So since it's not bigger than 24, these would be this situation where those two smaller sides cannot touch each other, and therefore they wouldn't form a triangle. All right, now here's another one. So on this one, we want to find all the possible values that this side of the triangle could be. We already know this one's 7 and this one's 10. Well, in order to do this, we have to look at two situations. What if this side were the biggest side? Well, if that side is the biggest side, so let's say that X is the biggest. Okay, so if X is the biggest, then these two have to be bigger than this one when you add these two together. So let's write that out. 7 plus 10 has to be bigger than X. So that tells me that X has to be bigger than 17. Or X has to be less than 17. Flip this one around. And we get X is less than 17. So I know that this one has to be less than 17. But is that all? No, because I don't know what this side is. What if 10 were the biggest side? If 10 was the biggest side, then we should be able to prove, so if 10 is the biggest, well, then we would need to say, okay, if 10 is the biggest side, then 7 plus x would have to be bigger than 10. All right? Just because it looks like it's the biggest side, we can't assume it is. So I would subtract 7 from both sides, and I'd say x is greater than 3. Now, if we were to graph these two inequalities on a number line, here's what we would find. So here's 3 over here, and then on a number line, 17 would be over here, 0 would be somewhere around here-ish, okay? So this one says x has to be less than 17. So we put an open circle on x because it can't be equal to 17. And then less than goes this direction. So we know that our x value has to be smaller than 17. But at the same time, we know that x has to be bigger than 3. So x has to be bigger than 3. So what are the values that would work for this one? Well, it's everything between 3 and 17. So x could be 4. It could be 5. Oh wait, why did I put 0 there? I am really freaking out today. I am not doing stuff well. Pretend like I didn't write that, please. Ooh. Okay, sorry, it's really late. Anyways, so this is telling me that my x values have to fall between 3 and 17. Now, how would I write that? I would write it like this. 3 has to be less than x, and x has to be less than 17. I would also accept between 3 and 17. I really don't like that, but whatever. So between 3 and 17. All right, let's do one more of those. So here's the next one. Okay, same type of problem. Okay, so we have to say, what if x was the biggest one? So x is biggest. If x is the biggest one, then 15 plus 24 has to be bigger than x, because two of the sides are always bigger than the third side when you add them together, the sum of two of the sides. So this tells me that x, so 15 and 24 makes 39. 39 is greater than x, or if we flip this, that would be written as x is less than 39. Okay, what if 24 was the biggest side, which looks like it's probably more likely. If 24 is the biggest, notice that I'm not even trying 15. 15 can't be the biggest already. I know that because we got 24 there. So the only two possibilities are this is the biggest side or this is the biggest side, because 15 can't be the biggest. All right, so in this situation, I would say that 15 plus x would have to be bigger than 24. So if I subtract 15 from both sides, I get x is greater than 9. So doing my little number line, and I won't put 0 in the wrong place this time for some reason. If I'm doing my number line, 9 would be over here, 39 would be over here. This is saying that x is less than 39, so open circle on x going this direction. And this is saying that x is greater than 9, open circle on 9 going this direction. So it looks like every value in between 9 and 39 would be possible values for x. And again, how do we write that? 9 is less than x, which is less than 39. Or between 9 and 39. Now, some of you are like, oh, that's hard. That's a lot of work. There's a shortcut. Let's look at our numbers. 3 and 17. Where did those numbers come from? 10 minus 7 is 3. 10 plus 7 is 17. Oh, it has to be between these two subtracted and these two added together. Look at this one. 24 minus 15 is 9. 24 plus 15 is 39. So it always has to be between these two numbers subtracted from each other and these two numbers added to each other. That's what you know has to be the value of x. All right, I'm going to blow your mind on this next one. Number 5. I've got two triangles here, and I want to know which side is the smallest. So which side is the smallest? Now we have not enough information here. We don't have all the angles yet. So let's fill in the angles first. Okay, here I've got a triangle. This is 40, this is 90. So this side, if I use the triangle sum theorem, it has to be 50. Because 40 plus 50 plus 90 equals 180. Over here, I've got tick marks here. This means this is an isosceles triangle. If these are the legs, then this is the base, which means that these two angles are both 72. Okay, so if this is 72 and this is 72, that adds up to 144. So if I do the triangle sum theorem, I would find out that this last angle is 36 degrees. All right, of all these sides here, which one is the smallest? Look at it real close. Remember we said that the smallest side is made by the smallest angle. Did you pick BC? Well, you're wrong. It's not BC. And now you're saying, wait a second, you said the smallest side made the smallest angle. Yes, the smallest side in this triangle makes the smallest angle. BC is the smallest side in this triangle only. Okay, so this triangle is saying, this is my smallest side. And if that were the only triangle that I drew, I would agree with you and I'd say, yes, go have a cookie. That is the smallest side. But we have more than one triangle here. We've got a second triangle here. This triangle is saying, okay, I've got 40, 50, and 90. So 40 degrees, that's my smallest side. And if I was only looking at this triangle, I would say, yes, go have a second cookie. CD is the smallest side of that triangle. Now our problem is these two triangles are connected. I cannot compare 36 with 40. Why? Because they're in different triangles. We can only compare angle measurements from the same triangle. So how do we solve this? We have disagreement. This guy's saying this is the smallest side. This guy's saying, no, it's this one. Who's right? Well, we're going to look at this shared side here to find out who's right. So this guy's saying, hey guys, this is the smallest side. I'm this triangle over here. This is my smallest side. This triangle says, oh really? That's my medium side because 50 is the medium. Therefore, this one's even smaller than that one is. So there's disagreement, so we have to see who's right. Because when people disagree, not everybody's right. On this side, it's small, but on this triangle over here, that is only the medium. So that means that this side is even smaller than this side would be. So my smallest side, just follow the arrows, is this one, CD. Remember, you cannot compare angles from two different triangles. They don't compare. You can only compare angles in the same triangle. So even though this is the smallest angle of all these angles, you can only use it to compare sides in this triangle. Since they said this is the smallest one, this triangle over here has said, no, that can't be the smallest one because that's my medium side. So that means this one's even smaller than that one is. I mean, they're saying, okay, yeah, that is small, but this one's even smaller. The end. CD is our smallest side. Done. Moving on.